Everybody, in this lesson, we're going to be looking at factoring quadratic expressions. So the standard that we're working towards is one where we're going to be looking at solving equations and inequalities in one variable. Specifically, we're going to be looking at solving quadratic equations eventually. And we're going to look at one of the methods that we need to know, which is factoring. So in this lesson, we're going to make sure that we can factor a quadratic expression. So the first method we're going to review is one called the greatest common factor. And no matter what type of polynomial it is, quadratic or a greater degree, this is something you should always do, is always look for a GCF. Remember, a common factor is something that multiplies 1, 2, or all 3, or all 4, however many terms there are. So when we're looking at number 1, I look at the coefficients of any variable terms and any constants, and I look to see if there's anything that divides all of them. So 12 and 18, I know that 6 is a GCF of 12 and 18, and it's the biggest one because 6 times 2 is 12 and 6 times 3 is 18. So what I'm trying to do is just rewrite this expression as a product of factors. So I'm going to divide each term by 6. 12 divided by 6 is 2. My k is still attached to the 2. And then 18 divided by 6 is 3. And the minus sign stays in between. Let's go ahead and look at number 3. So on number 3, I'm first going to look at all of the coefficients, 14, 35, and 7. And I know they're all multiples of 7. And you always, if you're not too sure, always look at the smallest term, and see if that number goes into the other ones, and it does. The other thing is I notice is that they all have an m attached to it. So I'm looking to see how many m's that they have in common. So there's m to the 6, m cubed, and m squared, and I notice that they all have at least m squared in common. So I'm going to factor out a 7 as well as an m squared. And now I'm going to look at what remains. 14 divided by 7 is 2. M to the 6, when I take out that m squared, it leaves me m to the 4th. And then I have negative 35 divided by 7, which is 5. And when I take out the m squared, it leaves me m. And then negative 7m squared divided by 7 is negative 1. And when I take out the m squared, it doesn't leave me any m's. So it's a product of 7m squared and then 2m to the 4th minus 5m minus 1. So these are each considered to be factors. Remember, factors are things we multiply to get a product. Okay, now here's where we're talking about a trinomial that's in the format x squared plus bx plus c. And this can also be negative, not always positive. So that's why it says trinomials where a equals 1, because this coefficient of x is equal to 1, and 1 times x squared is just x squared. So the easiest way to do these, and we'll be talking about this later, is always by looking at your constant, which is always going to give you your target. Okay, so our target here is a product that's equal to our constant. In this first one, it's positive 45. Now, two things you need to know about a positive product. It can either be gotten by multiplying a positive number times a positive number, or a negative number times a negative number. Another thing to know about trinomials that factor, they're always going to multiply as two binomials. Okay, now the other thing is, this is my target product. I'm also going to be looking for something called my target sum. My target sum is always going to be the b term when a is equal to 1. So I want my target sum to be positive 14. So I need two numbers that add up to positive 14, and they have to multiply to make 45. And I'm not going to sit here and exhaust you with this list. I'm just going to go straight to the one that I know is the correct answer. And now I'm looking for which of them have a sum of 14, and it's positive 9 and positive 5. So what does that mean? It means, well, to get x squared, I would have to multiply x by x. And to get 45, I would multiply positive 9 times positive 5. Now, if you remember FOIL, first, outer, inner, last, and we multiply all that out, we would get x squared plus 14x plus 45. Now let's look at number 8. So now my target product is negative 72, and I need my sum to be negative 1. So if my product is negative, that means one number has to be positive and one number has to be negative. And if my sum is negative 1, I need the larger number, or the one with the greatest absolute value, to be negative. So thinking about my numbers that multiply to make 72, I know that it has to be a positive 8 and a negative 9. And if you're not sure how I'm figuring that out, I'm just going through things that multiply to 72. And sometimes you actually have to sit there and do this a little bit. And this is an exhaustive list, so that's why I didn't go through all of them. But that's how I'm going ahead and doing it. Okay, so back to my factoring. So I know that in order to get a trinomial, I have to multiply two binomials. I know it has to be n times n to get me n squared. And I know that one of these has to be positive 8 and one of these has to be negative 9. Okay, now we're going to look at number 12. So first thing I notice is that these are all multiples of 5. So the first thing I'm going to do is I'm going to factor out of 5. So that gives me 5 times z squared minus 5 times z plus 6. Now, I'm going to forget about that 5 over here for a minute, and I'm just going to pretend this is just like everything else that I did before. So I'm looking for two numbers that multiply to make 6, and this time I want them to add up to negative 5. Now, if two numbers multiply to make a positive, remember that they could be both negative or both positive. But a positive plus a positive doesn't make a negative, which means they both, in this case, have to be negative. And the numbers that multiply to make 6 are 1 and 6, or 2 and 3. And these are the only two where a negative 2 and a negative 3 would make a negative 5. So I know it's going to factor like that. So I have 5, and then my two binomials, z times z, negative 2 times negative 3. And how do you verify? Remember, you would go ahead and you would distribute 5z minus 10, and then I would go ahead and multiply that by z minus 3. 5z times z is 5z squared. Negative 10 times negative 3 is positive 30. Negative 10z, negative 15z makes negative 25z. Now here's where it gets a little bit harder, but let's not worry too much about it. And we're still going to be looking for a target product, but this time our target product is going to come because A is not 1. My target product is the two numbers that multiply times A times C. The target sum, however, still comes from the same term, which is always going to be my B, which equals negative 15. So I need two numbers that multiply to 36, and they have to add up to negative 15, which means they both have to be negative, because a negative times a negative makes a positive, but when you add two negatives, you get a negative. So going through my numbers, I have 1 and 36, 2 and 18, 3 and 12, 4 and 9. And remember we said they all had to be negative because a negative times a negative makes a positive, but the sum of two negatives is negative. Can't be these two, they add up to negative 13. These added to negative 37, these added negative 20. It has to be negative 3 and negative 12. Now here's the problem. We can't just go ahead and put those two numbers in. So we're going to go ahead and we're going to use a method that uses the GCF again, twice. So this one is target, factor, split, pull out. And I like to use a box to do the pulling out, and I'll show you how to do it. Okay, so we already went ahead and we figured out our target was 36. The two factors we needed were negative 3 and negative 12, and here's our split. what we're really going to do is we're going to take our trinomial and we're going to make it a 4-term polynomial by splitting negative 15x into negative 3x and negative 12x. And I'm not changing anything because my sum is still the same and I had simplified it. But what it does is it gives us the ability to pull out common factors so we can get 2 binomials. And that's because 2 times 2 is 4. So it gives us our 4 terms that we need. And then later on we simplify. Okay, so what I'm going to do for my pull out is I'm going to use a graphic organizer. And this graphic organizer is simply a square or box. So I call this the box method of factoring. But basically we're going to be pulling out common factors. So I'm going to take a square and I'm going to separate it into 4. And I'm going to go ahead and I'm going to put all 4 of these terms, 1 in each box. 2x squared, negative 3x, negative 12x, and positive 18. So now what I'm going to do is I'm going to first look at this column here. And in that column, I want to go ahead and I want to see what is the common factor of the 2 terms. So I see they're both divisible by 2, and x squared and x have a common factor of x. Next, I'm going to go ahead and look at this column. Negative 3 and 18 have a common factor of 3. The question is, should it be a negative 3 or a positive 3? And how I know is that first factor that I'm pulling out of, negative 3x, is negative, and that's why I'm going to put a minus sign here. So we know we need a binomial times a binomial. So where the second binomial comes from is by doing the rows. So when I'm looking at 2 and negative 3, they don't have anything in common other than a 1. But x squared and x have a common factor of x. When I'm looking at 12 and 18, I know they have a common factor of 6. They do not share an x because only the 12x has an x. But the negative 12 is negative, so it must be a negative 6 that they have in common. So we're pulling out the common factors, and we get 2x minus 3 times x minus 6. And if we multiply that out, we will get exactly 2x squared minus 15x plus 18. Now let's look at number 18. So remember, the first thing we always want to do is look for a GCF. And so I see that my terms are 16, 60, and 54. Well, I know that 16 is divisible by 4, but 54 is not. I know 54, in addition to being divisible by 2, it's also divisible by 3. So is 16 divisible by 2 or 3? It's divisible by 2. So I'm going to go ahead and I'm going to factor out a 2. So 16 divided by 2 gives me 8. 60 divided by 2 gives me 30. And 54 divided by 2 is negative 27. Now, there's nothing else that divides all 3 of those terms, so I'm done with the greatest common factor. So now remember, I'm going to do my target. And so remember, the target comes from A times C. Now this time it's going to give me a pretty big number. 8 times negative 27. It's kind of huge. It's negative 216, which tells me one of my numbers in my factors, one is positive and one is negative. And remember, my target sum is going to be a positive 30. So I need the larger number to be positive and the smaller number to be negative. And now I know that they're 30 apart, so I know that I want one to be a much bigger factor than the other. Okay, and doing a lot of playing around, I figured out that it's 36 and 6. 36 times 6 makes 216, but positive 36 plus negative 6 is going to go ahead and give me positive 30. So now I'm ready to split. And so remember when I split it, I still have that 2 there, and I'm going to ignore it for a little bit. So I'm going to put a box around it. And I know I have times 8m squared plus 36m minus 6m minus 27. And so remember, each of those four terms is going to go in my box. So I have 8m squared, 36m, and go this way. So what's the biggest number that goes into 8 and 36? That would be 4, and they both have an m in common. -6 and -27, both are negative, so you definitely have to pull out a negative. But remember, because the first term in that row is negative, that's why we're pulling out the negative. And 6 and 27 are both divisible by 3. So when I go ahead and I've pulled out the common factors, I have my first common factor was 2. My next set of factors, 2m plus 9. And then my second, 4m minus 3. And last but not least, we have difference of squares. Difference of squares is a rule that you just pretty much need to make sure you remember. And it works like this. It says that whenever you have two perfect squares that are being subtracted, it always factors square root minus square root times square root plus square root. Now remember, your perfect squares are numbers that when you square them, you get that factor. 1 is a perfect square. Since 2 squared is 4, 4 is a perfect square. So for example, again, 9 squared gives me 81, so 81 is a perfect square. So now let's go ahead and use the rule. So we're going to do number 23. So first I examine my factors, or my terms, excuse me. 9 is 3 times 3, 25 is 5 times 5, x squared is x times x, and y squared is y squared times y squared. So I know it's definitely a difference of squares. So what's the square root of 9? 3. What's the square root of x squared? X. So that means both factors have to have 3x in them. And now I go ahead and I do minus and a plus. And now 25, to get it, I have to square a 5. And to get y to the 4th, I had to multiply y squared times y squared. Now let's go ahead and look at number 26. So remember, the first thing we always want to do is look at common factors. 2 and 32 are both divisible by 2. I see an a squared and I see an a to the 4th, which means a squared is in common. And they both are divisible by b. So that leaves me, when I take out a 2, an a squared, and a b, I get a 1. When I take out 2 from 32, I get 16. And I took out an a to the squared from a to the 4th, so that leaves me a squared, and I took out the only b. So now I have to think about, are these terms perfect squares? 1 squared is 1, 4 squared is 16. So yes, this is a difference of squares. So my original factor that I had pulled out was that. So now I'm going to go ahead and take this and factor it as a difference of squares. So I know it's 1 times 1, 4 times 4, and to get a squared, it's a times a. 1 gets a plus, 1 gets a minus, and it doesn't matter which, really and truly, which one gets the plus and which one gets the minus.